Welcome, everyone. I hope you have a good coffee ready for our webinar today. We're going to cover a lot of exciting topics under the theme of practical AI use cases for manufacturing and industrial operations in general. And without further ado, during the presentation, if you have questions, just put them in the question segment that you have as attendees, and we will answer those during the Q&A session at the end. But if you don't want to forget about your questions, just put them in there, and we will treat them as they come in later in the Q&A session. So without further ado, the presentation today will be led by two people. One of them is me, Remy Duquette. I'm the Vice President of our Industrial AI Group at Maya HTP. We've been a long-term partner with Siemens, and I will let Francis introduce himself.
Hey, hi, good morning, welcome everyone. Appreciate your time. For this webinar, I'm Francis Varakancheri. I'm part of the Siemens organization focused on a smart connected factory, bringing the different elements together, where we bring the real and digital together. So I'm hoping to share some of our learnings in this space. And my focus has been on the hardware and the software and how we are leveraging this in a manufacturing context, which is foundational to what Remy will be talking about in use cases and from my side as well. So look forward to the next 45 minutes and I hope to learn something new from you folks as well. So just to introduce Siemens, I'm sure Siemens is a name that's familiar, and as you can see, Siemens is an industrial powerhouse, a market leader in the automation, electrification domain. What probably most of you or many of you are probably not aware is Siemens is also the market leading industry solutions software provider as well. And we have an extensive amount of domain expertise we bringing the real and digital together. And part of that is also how we are actually helping outcomes in the shop floor, leveraging AI. So today we hope to share some of that learnings, keeping that AI as the focus, but also look at it from how we can actually optimize it, leveraging a lot of the hardware and the domain expertise we bring in, and it will become very evident as to why that's an important part of the AI journey as we speak. When we look at it from our industrial IoT strategy and how we align with our customers' needs, it all starts with the idea of bringing the real and digital together. So the real digital becomes your comprehensive digital twin, which maps out the entire product lifecycle. But once you connect it to the product or the equipment, we're now bringing the real digital twin as well. And data becomes the cord that ties these two together, bringing it into life. And that's where closing the loop becomes important. From a shop floor perspective, we are talking about the ability to connect, collect, and contextualize it as information that you can access at your equipment level or a machine level, or what you'd like to do it at the edge as we talk, which is nothing but what you do on the machine. But I think more importantly, being able to bring all this data, which we do in a cloud ecosystem as part of what runs on a hyperscaler. But I think the key value proposition is the ability to use services in the form of SaaS, software as a service applications, which can drive outcomes with specific use cases that we will be talking about, and being able to do it all at scale. So being able to do this with personalization becomes an integral part of how we actually bring in, and I think low-code is an integral part of the stack that we bring to customers as well. But foundationally, the key is how do we make it open and flexible to meet the customer where they are when it comes to their ODID integration. And we'll talk more about it once Remy gets to cover some of the outcomes, because I think that's what we all care about. And we will also cover the means to those outcomes and the journey. So back to you, Remy.
Excellent. Thank you, Francis, for the intro to Siemens. From a Maya and Siemens perspective, to give some perspective here, Maya is the #1 worldwide partner in 2022 of Siemens from a digital industry software, and now, combining factory automation and digital industry software together, Maya can serve as a system integrator to make sure that all the data that you acquire through the great connectivity that Siemens hardware and software provide, then we can make sure that the business use cases that you're interested in materializing and enhancing will be done properly. So from a Maya standpoint, we have 75 plus system integrators dedicated to the Siemens portfolio. We have authored even some modules within the Siemens software family, so we're very well integrated within the Siemens portfolio and family. And most of our staff, we're very technical in terms of a company. 75% of our staff are scientists and engineers. I'll talk about the data scientists, but most importantly, probably for a lot of you, data engineers and engineering, process engineers that understand your reality and the physics behind what you're trying to measure and monitor. From a delivery standpoint, Maya has a great track record. My team has deployed over 4.5 million sensors and telemetry points that our clients gather out of about 150 projects alone in the last 10 years. So that's really tribute to how much we have now been able to accomplish and put in real production with real adoption in the manufacturing and industrial production and industrial operation use cases. So we'll get to there. We leverage, of course, third-party tools. So if you need to connect any of the data from third-party systems into Insights Hub, we'll get to that, with Francis a little bit later. Whether you use Siemens Edge device and push that to cloud components, any integration to third-party systems, Maya, of course, as a system integrator, will bring that data in a centralized way so you can contextualize it in the right way. So that's really our expertise, is really in the industrial AI and the industrial data connectivity aspects in software development. When we talk about the use cases, we talk about asset condition monitoring, increased productivity and OE. We look at energy efficiency. A lot of wages type of initiative on the sustainability side are starting to materialize. Increased product quality has been a great focus, and I've been on many podcasts before. So if you're interested, we can connect later. But really, we do it and we meet you where you are. I think Francis mentioned that, and that's a key element of both Maya and Siemens in terms of our approach, which is to make sure you can walk before you run and before you jump into AI. AI is not a magic wand. It's a wonderful and very powerful technology, but it needs to be harnessed in the right way and at the right pace of introduction for adoption in your industrial environments. So this is where Maya provides these Industry 4.0 consulting to make sure we understand your business use cases, where the data is today, then put some data engineering, data fusion from multiple sensors, whether it's video, telemetry, audio, different types of sensors, and then put some dashboards understanding the reality, and then bring in the ML machine learning operations and AI into the fold. So really a nice organic way of deploying these use cases. As we said before, the business use cases, we'll list those here, and you'll have to, from a poll perspective, we'll ask you what is of most interest to you, so we make this webinar a little bit more dynamic. But really, this is where you need to start. Focus on your business challenges today, and then let's align on where you can and cannot or should not apply AI technologies to it, right? So there are some good use cases to apply AI technologies. There's some maybe not so good way to start. So that's really where you start the digitalization process, look at what's happening in the environment, and then you move to the end game, which is really applying the machine learning to it. So maybe as a first level set, I will start a little polling. You'll see on your screen, I'm going to launch the polling here. and you will be able to choose amongst, what describe your current AI maturity. So from a machine learning, deep learning perspective, have you started to think about AI or not yet? Have you started to plan out various projects, proof of concept, perhaps some proof of value that you've started to deploy in your environments, and maybe you already have some AI algorithms running into production. So just go ahead and select what's most appropriate to you. And I think, Francis, you'll agree with me, probably the average will be closer to the maybe B or C, depending on the maturity level. But from an industrial standpoint, in our client base, that's what we see. Do you see the same thing on the Siemens side?
Yeah, absolutely. I think it's one of those, there's a lot of interest, but I think when it comes to really starting it in the context of POC, I think everybody is in the phase of trying to figure out where do I start or try it out in very selective pockets. But I think it's got a journey to make.
Yeah.
To validate.
And let's share those results with your polling results from the crowd here today. I think not, let's say out of norm, you're very in line with what we see in the manufacturing and industrial operations. Most of you, 43% of you, have said that you've started planning a first AI proof of concept or proof of value, but not started yet. So you're still in the planning phase to understand your business use cases. So we'll dig into what the best practices are there, perhaps for you guys to get started in the right way. And then some of you have started, right? The 13% already ran a few proof of concepts, and some of you have already have some AI algorithms ran into production environment. Hopefully you're some of our 150 clients that have mentioned that in adoption there. And then 4%, that's the rare case of you have a culture of AI first. So this is very interesting, and we'll continue the presentation, but that helps us understand where you're at from a crowd today on the webinar. So maybe just as a level set in terms of evolution or revolution from an AI perspective, a lot of attention is given to AI over the last decade, and certainly over the last 8-9 months, thanks to our friend ChatGPT that came on from OpenAI. But in the end, when you look at the various elements, right, in January 2016, AI was not even amongst the 100 most searched terms according to Gartner. And then, by May 2017, all of a sudden it jumped to rank number 7. And now, by January 2023, even my mom is talking about ChatGPT, right? So we've seen this kind of exponential awareness of AI, and there's a lot of buzzwords. So today we'll go down to the practical implementation and what it means for manufacturers and in real adoption environment. And what fueled that AI revolution, from a standpoint of making it adoptable and deployable in your environment is really 3 factors or 3 vectors. The compute power, clearly the rise of GPUs, so the graphical power units that have come up to speed and surpass a lot of the CPU components. So that was for Matrix, kind of operations. That was a huge kind of push to propel really AI into the limelight and the spotlight. Data quantity and access. I mean, from a manufacturing standpoint, operation, typically you've been collecting data for a very long time. So from a data quantity perspective and data access, you're actually ahead of the curve typically when we meet manufacturers. Now, sometimes you've been, evolving your process in small steps, right, and small quantifiable little improvement and constant improvement. So your data may not have the variance needed for AI to learn from it. We'll get to that later, but that's a big element that you want to consider when you go into AI. Do I have enough variance in my production data to actually leverage deep learning models? So that's another set. And then the open AI tools, including the latest open source model from large language models that have been Llama V2 and others that have been open source. So there's a lot of open source components from a deep learning and AI revolution that are fueling that adoption. And when we look at AI, a lot of people think of it as a visual kind of component, and here we see that starting in 2016, essentially convolution neural networks, deep neural networks became better than humans. And when we say better than humans, if you're like me and you need to reset password or prove that you're a human being, you're going to say, okay, where are the bridges or the bicycles on this image? And sometimes it's not quite clear which square you click on, right? So that's the error. The human error rate is roughly about 5%. Or a cheetah or a leopard, right? Unless you're very familiar with these animals, you may not know which one it is, right? So those are kind of the human errors that will come into the fold, and AI will be better than us, and that's fine. From a paradigm shift, though, it's really learning by machine instead of programmed by humans. And there we saw in 97, by brute force, which is totally understandable, Deep Blue beats Gary Kasparov. But that was kind of a brute force approach. That was not learned from data. So here, what we see now in the last decade, what we've seen is, for instance, on the chess side, a software built by human beings over about 10 years period, right? Stockfish was destroyed with 4 hours of self-learning and reinforcement learning to self-play against itself to learn to play the game and win the game. So this is kind of the paradigm shift. It's now you have environments that you can play against and learn from in a reinforcement learning approach, and that provides very interesting output and outcome. From a real-time data perspective, if you turn on those kinds of machine learning controls that have been, again, learned from data and learned from self-playing against, you can imagine a system-level simulation model that represents your cooling plant in the case of the data center. Well, it can learn to better control your data center, and you can see the shift in terms of the curves and the improvements on the energy usage that you get, right? So a lot less energy used when the machine learning control is on versus off. And that's totally normal because PID controller are very robust, but they're known to not be as efficient. That's really where the key aspects can happen. What are we talking about in terms of data, right? Data comes in various forms. You probably collect in your manufacturing shop floor in industrial operations a lot of traditional sensors, time series data. You have hundreds of dashboards, sometimes thousands I've seen at some of our clients. So lots of screens that you could look at, and then the problem becomes where's Waldo? If you're trying to access a specific data stream, it may take you a while to get to the right dashboards, even with drill through and smart ways of using dashboards. But in any case, it can be still cumbersome. On a video as a sensor, right? So as we've seen, AI has been very good at recognizing patterns inside images. Images may come in different form. It can be a thermal imaging camera, or it can be a stereographic camera that gives the depth of the viewpoint. So those are opening up new business use cases that you can tackle in your shop floor using these new techniques. Another one is audio as a sensor, right? So you can turn audio into the frequency spectrums that you get from a simple microphone, and you don't need, perhaps in some cases, a very expensive vibration sensors, and you can get the frequency to lead to understanding the predictive maintenance, or that something dropped on the floor that shouldn't be dropped, or a little bolt that fell inside a piece of equipment that's not supposed to during assembly time. There are various things that you can avoid or pick out from an audio as a sensor. The last one is large language models, so textual type of data, right? So you've seen, and you've probably played with ChatGPT and GPT-4. The topic here is not going to be on GPT, but I wanted you to see the evolution of these models from 2019. Actually, the inception of the transformer technique was in a seminal paper in 2017. So we've been tracking these evolution for the last 6 years, really. And now we see that these Llama models and ChatGPT models, GPT models are really good, and we can leverage them, for instance, to provide a chat interface to your technicians offline, not using a cloud-based GPT version that has learned from your private data, but deploy a local open source model that can interact with your technicians to access your own technical documentation. So that's an additional use case that's a little bit more recent inside there. So how do you benefit from AI, right? As we said, you collect the data, you visualize, contextualize, you understand what's happening, and then you predict and you control. So that's really the steps, the general steps to the top. And you may have different use cases based on your industry. So depending on where you're from, new after-sales services bring additional revenue. CFO will love you for that. If you're looking at product quality metrics, you really want the extra mile. Well, the extra mile today might require an AI model or machine learning model to get implemented. Predictive maintenance, asset remaining useful life, all very good use cases. And as you get started, 40% of you are getting started with your first planning, your first proof of value or proof of concept. I prefer proof of value because that means you're going to actually use it and deploy it in a minimal way, but you can actually deploy it in production. What we typically do as a Industry 4.0 type of advisory role initially is to rank with you which of your business use cases are of higher priority. And we rank them in multiple ways, multiple axes, but the two main ones really, if you look at business use case value, so what value you're going to get if you do resolve that business challenge that you're being affected by, and we will be able to give you the time to implement from our experience in these 150 plus projects, and we'll see some of these client use cases after Francis covers some of the technological and deployment aspects from a Siemens perspective as well. So before we get there, let's go to the second little polling so that we get to understand what you guys are most interested in. So, in terms of your interest, which business use cases or challenges are you facing today where you think maybe machine learning and AI or better industrial technologies can be helpful for you? So there's quality of products, increase the manufacturing productivity, reduce downtime, improve your PID control loops, create new after sales, data-driven type of value services. I don't know, Francis, is out of these, which you think might bring most interest for our users?
Yeah, I think AI, in general, is mappable to all these, but I see the second and the third seems to be kind of people tend to gravitate more towards those, and partly because there's an opportunity to do it at scale, or you want to do it at scale to derive the value. But again, we are seeing this shift over time.
Yeah. No, I think, and we'll share in a few seconds, the polling are still coming in and varying a little bit, but I think we can probably close it now and share with the viewers. There we go. So as you can see, a lot of you have looked at or are interested in manufacturing productivity, and that's absolutely a great way to start, right? For two reasons. typically you do have very specific metrics that you're tracking today. So you're already monitoring productivity in your line, or your, by product, by week, by shift, by all different dissection of the data that you're collecting today. So actually, implementing an AI model to help will be a great use case, because you'll see the metrics evolving very quickly because you're already monitoring them. So you know what your starting point is, and you'll see how it affects, how AI technologies affect those metrics over time. This is a great way to start, and at scale, as Francis mentioned, is a great way to get going. Quality and reduced downtime. So product quality is another big one, and another one that most companies that we've deployed also have looked at and ranked very high up and have put in production and adoption. And reduced downtime is also a third one. And I think, Francis, you'll have a lot to cover there on the predictive maintenance side, which is the second here from maybe close to equal with quality of products, but still very high. And then the last two, it's kind of interesting, the 20% of creating new after-sales data-driven value services. Most people now are gravitating towards that once you get a certain maturity level. And the reason is it's added revenue. So a lot of people in your company will be interested in that one because it generates a new stream of revenue. And a lot of people really, of course, enjoy that. So let's close this here. And to next section. So how to solve your use cases faster. So I think here we'll see from Francis, how you can leverage the power of the Siemens solutions, and then I will piggyback that on the services that Maya offers to get those solutions implemented and adopted in your environment. Francis?
All right. Hey, thanks, Remy. I think Remy gave a great context of how AI has evolved. So I almost look at it as it's become much closer, much more accessible. And now that has given the opportunity for us to now embrace it better. Two data points I picked with the polls, and interestingly, one was a direct function of why scale was important in terms of how you are looking at it aspirationally, as well as what your experience was. And the poll that we just did was also talking about use cases which are around manufacturing productivity, downtime, asset improvement, and then of course product quality, which are all things that you have an opportunity to do at scale. The key for Siemens has been helping with our ability to do the insight gathering, which all starts with connecting and collecting data. And our background on the hardware and the automation over the last many decades have really come in very handy when we are trying to bring the real and digital together. And connectivity becomes a key part of how we actually get to different plants and different heterogeneous OT environments. So the ability to leverage the hardware and software options in a very open and flexible way becomes key to how we actually help with the OT-IT integration. Now, talking about the OT-IT integration, if you want to go to the next slide, as you can see, the key is, as I mentioned, foundationally, the connecting and the collecting and the contextualizing. Now, when we talk about providing the integration, think about that as the plumbing that you need to put in place to drive operations excellence. For example, being able to provide operational and energy transparency becomes the foundation for you to drive, be it your smart manufacturing, smart connected factory initiatives, or even things like sustainability and the KPIs that you drive at a plant, for example. So how do you make a start? And I think the comment that one of the customers made is a perfect example of, we are rich in data, but poor in insights. And I think my conversation over the next 6 to 8 minutes, I'd like to emphasize that how we make that transition of taking your data and translating that into KPI-driven analytics to start with, so that maturity index evolves as follows. We are able to take it from the level of business intelligence to bringing in AI ML to drive predictive and other prescriptive insights, and being able to do all this in a SaaS context becomes key. being able to also leverage these in personalized applications and driving it. And we have a standard set of applications which actually make AI accessible to citizen data scientists. Think about it as personnel who are actually operators, maintenance personnel, and others who are not data scientists, but how can they benefit out of some of the solutions and the capabilities to drive very specific outcomes. So today we're going to double click on a few of those examples and also give you a context of where all this comes into play in terms of our solutions and capabilities, which builds a foundation for what Remy is talking about in terms of being able to bring in experts and actually being able to provide you more tailored solutions. So to start with, we have a citizen data scientist tool called AI for Everyone. Think about it as you're getting all this data, or the raw data that's coming off machine. You would like to understand the correlation of which data or which parameter where I'm seeing potential anomalies being detected are actually be contributors for, which parameters are contributors for something which could potentially be a critical data that I need to monitor. And the tool basically builds an AI model behind the scenes, giving you the opportunity to select a large set of attributes and identify the key candidates. Now, this drives using an anomaly detection algorithm to identify anomalies in the context of other attributes, but also use that as a basis to even provide prognosis and being able to do some trend or forecasting. Now, this is the foundation that services like what Maya can bring to the table can actually help build more mature, comprehensive data models tuned very specifically around problem areas. Another example, so this was an example of what I would say customers who do not have the resources of data science and they want to leverage it. But if they want to leverage it and they have resources, or they want to have an environment where they would like to bring in partners like Maya to actually help with, we have a predictive learning workbench environment where you are actually going to be bringing in the ability to bring your own tools, for example, open source tools like what Remy was showcasing, and use the data that we are bringing through our OT/IT integration and work through the whole machine learning DevOps, where we are not only housing the model, we are using the data to train the model, and we will deploy the applications and go through that loop of continually training and have the ability to deploy the updated models. And that becomes a key part of how we drive it. Now, when we want to look at more mature, let me try and address this at scale solutions, where you would like to do it. That is where we get with applications which are in the domain of predictive maintenance. So if you want to go to the next slide. So AI has tremendous potential to drive use cases. I think this is one of the key use cases that Remy touched upon as well. And what we bring to the table is an application called Senseye, which can actually do it at scale, empowering the operators and the other maintenance personnel with the ability to start with health monitoring of assets, which becomes the basis, but then use Insights Hub and the evidence-based conditioning data to actually drive outcomes with the AI model, where it can start looking for anomalies as well as any operator experience-based incidents. And those incidents become what we actually review, validate, and root cause before you actually pass it on to your enterprise asset management system and others. So the ability to bring in a broad set of equipment into play from a predictive maintenance standpoint and build fidelity of the data and the insight using AI ML over time becomes key for how actually an solution like this can be scaled. Let me walk you through a scenario which I think, based on our interactions with clients, is very compelling, and a lot of customers are looking at this. It starts with the ability to bring all the data and providing that closed loop maintenance process and operation. So you start with having the baseline. So we talked about one of the use cases of improvement of OEE, and you're going to use the operational efficiency KPI as a basis to monitor. And once you identify that the assets are showing behavior which is out of the normal, you create incidents which then get piped into your health and maintenance application. And these are analyzed and root caused to weed out the false positives, because that's how you learn and that's how you make it richer in terms of your insight. And managing the ticketing system that a maintenance management system or an enterprise asset management system manages becomes the key insight. So the action and the incident context becomes the input that feeds back into the system. And the next time a similar kind of an anomaly is identified, number one, it beats out the false positives, and two, it actually helps focus on providing prescriptive suggestions on what actions might be required, which is a learning from the previous model. So it becomes a closed loop system of how you're actually driving maintenance, and it helps with better prognosis and other areas like remaining useful life, which are critical when we are monitoring assets at scale. Because we're not talking about doing it for one or two assets, but we are talking about being able to do it at scale. So let me give you a couple of examples to emphasize why it is important to look at the data side of the equation, which is part of that digitalization journey, where you bring in the data and bring it in context. So this is an example of a customer where we actually had the ability to connect multiple plants from an OT-IT integration, pulling in energy and operational data, and the ability to offer a multitude of options which involved different ways of connecting to individual plants, which they had our own type of OT landscape, was key. And being able to do all that in a very short order, like 7 months, I think was key. And the only way it could do it was because of the breadth of connectivity options we had, and also the ability to now leverage all the data we are pulling in and make it available for use cases. Taking another example, which is more specific to a use case, where we are talking about predictive maintenance and being able to do it at scale. I cannot emphasize enough as to why it is important to look at use cases that, one, has the potential to scale, and two, actually does not make it effort intensive for you to actually be able to go and solve it at scale. So data becomes the key foundation, but then being able to leverage that data in a way that you're making it available to a citizen data scientist who can actually leverage it is what exactly this customer was able to do. And they were able to scale this across different machine types, because you don't want to build too much of proprietariness to a solution, because the way it's architected is it has the ability to use a machine signature unique to each instance of the machine, and use AI models not just to map out the behavior of the machine, but also the behavior of the operator. And I think it is important that you look at it holistically and how all that data feeds back into your workflow, so that you are able to replicate this particular use case and be able to take it both horizontally and vertically. And what I mean by that is scale it in terms of numbers without having an exponential level of effort, and also scale it in terms of added value that you can get by addressing one or more multiple use cases. So in summary, AI can be your best friend to drive outcomes, but keep in mind you want to approach it with something where there is a quick return on your investment of time to value, and also have the ability to scale. And having a foundation which can address that comprehensive set of AI solution needs is very critical. And it's probably a perfect segue for me to hand it back to Remy, who's actually going to walk through some examples. Back to you, Remy.
Perfect. Thank you, Francis. And yeah, it's definitely a journey with small steps. And to your point of infrastructure to scale up afterwards, I love your analogy of, when you build a house, you bring the electricity, main board into the house, and then it becomes easy to connect to the lamps or to the dishwasher, or to enable, right, the use of electricity in the house. So think of your data pipelines and Insights Hub pipeline as a core function that you bring in house, and then you can connect all the use cases to it and leverage the technology and the data for your use cases. Yeah, I love that analogy of yours, Francis. I've heard many times you say that, and I had to bring it up because you didn't mention it today for the first time.
All right, no, thanks for sharing it. I was just trying to keep the topic a little more richer as AI, but that's kind of a very simple way to look at it.
Yeah, no, it is. Yeah. So we'll go through a few use cases now of real implementation and adoption in manufacturing and industrial operations as well. So I will start here with a discrete manufacturing use case where the company was producing lithium batteries for electric cars. And they had two major business use cases that came on top from that prioritization and, of the use case that you've seen before that we've done with them. So we consulted as an advisor first to go through all the list of different projects that they thought they could apply machine learning and AI industrial insights hub type of technologies to deliver the value. And here you can see the two main things were the product rejection rates and quality variability was very high. So they needed to bring that under control. And then at the end of the production, they had a cooling time that was very long before they could actually do their final quality control testing. So what we did to help them is twofold. One, we looked at 16,000 real-time telemetry points out of 10 stages of manufacturing. So each stages had a certain number of real-time monitoring. And when we say real-time monitoring, some were true real-time, telemetry signals. Others were manual logs of different things that were done, like a cutter, like that's a manual kind of step. That was still in the telemetry, but of course as a timestamp telemetry, not real time, but a manual logging of different activities is sometimes very useful to leverage data, especially in the AI world. So these are different practices. In their case, at the end of the day, we were able to help them save about 400K worth of lithium per year. Doesn't look like a lot, but when you have to recycle that material and it's very flammable, there's a lot of other risks that are involved in the recycling and repurposing of lithium. Very explosive kind of material. So this was a big key thing for them. And then the last one, which is we were able at the end, their cooling time was of the order of, let's say, 24 hours, and we reduced it by 10 hours. So after 14 hours of cooling, we were able to, with machine learning, be able to, and understanding the physics of the cooling process, we were able to create a machine learning algorithm that was able to tell them at 100% certainty that they could actually pass the quality control with that battery. Of course, after even just 8 to 10 hours of cooling, we could have told them that they, with a high probability that the battery could pass, but they wanted 100% certainty. So the machine learning model essentially became 100% clear on that outcome after 14 hours. So that's why we still saved them 10 hours of production time per battery, which was huge for them and allowed them to move forward. So key business use case, very narrow focus on the end result, but in the end, we still put the entire piping and data pipelines needed to materialize that use case. So now they can turn on different lights and different use case in their factory, and we've trained them to become self-sufficient at the end of this first project. So now they're delivering their own machine learning models as an example here of people that become self-sufficient as we teach them the ropes and the best practices. Another one is in the continuous manufacturing, so shift completely from discrete manufacturing to continuous manufacturing in the pulp and paper, completely different industries. And I'm picking out these different industries and use cases and different production mechanism, from batch, continuous, and discrete, to show you that AI and machine learning can be helpful in any of those environments in different ways, of course. In this particular case, if you probably remember, just as COVID hit, everybody went out to buy some toilet paper and technical paper, as they call it. Manufacturers were essentially needing to augment the production all of a sudden. So that caused a bunch of quality issues because older individuals could not be on the shop floor for obvious health reasons. So in those cases, a lot of younger people were brought in to essentially operate these machines, and they didn't have the 30+ years of experience that the other folks had. So in this particular case, it was a twofold mechanism where the younger crowd were trying their best, but they were touching a bunch of stuff. And that generated actually a lot of good variance in the data. And remember, AI and machine learning learns from variance and variability in the data. And so for them, it was kind of a little bit of a problem, but that generated gold data that we could then leverage. So we essentially harnessed the order of 600 sensors, and we were able to predict a large amount of the 20 quality parameters in close to real time, and while we were increasing the productivity. So that all that benefited a lot of their plants to operate at higher capacity and produce the same or better quality without having all the very high experts on the shop floor during that time. So great improvements using better methodologies on the AI machine learning side. Now, a lot of people have asked me over the years, can you explain or show me what AI does really on the telemetry? And so one day I saw this example, and I thought, from an hydrotreater system in the oil and gas industry, this is a 24/7 operation, so slightly different again than maybe the continuous operation pulp and paper. And in their case here, they were using PID controllers. And as you can see, the asset useful life, when you're under a PID controller, you have a lot of swings and a lot of variations in the operational parameters that are being controlled for. And that kind of noise in the signal really impacts the asset useful life, right? It reduces the asset useful life. So when you turn on AI as a controller, you can still use, by the way, the PID as a fail-safe mode, right? So because you've been using PID controllers for 40+ years, so your process engineers and control engineers will probably say, we're not going to bring AI to control our systems until they realize that, oh, we could put an if-else condition in the PID controller loop, and when you're operating within certain constraints, maybe temperature range or pressure range or volume flow rate range or concentration range, then you can say, okay, during that time, I will use the better solution and turn on the AI control model to control the process. So in this case, you can see how well the AI can control, and much better than PID controllers, clearly. And so that's something that was turned on, and you can see how it evolves over time. And this is almost I think a half 3 hours segment that was cut out from the operations, but it's really since then they've increased it in all their hydrotreater system, and it's the baseline that they move forward with. On a completely different segment, robotic composites. So I wanted to bring a low volume production so that you don't think that you need, just continuous and very high production volumes. We can also apply AI in different ways by generating synthetic data using simulation models. So Siemens Digital Industry Software has a lot of simulation software that we can leverage. AIMSIM is one of them for more of the system level simulation that generates synthetic data where you are missing data. So think of failure modes, or if you don't have enough variance even in your normal operation, we can simulate for it and generate the data that's needed to train the baseline machine learning model, and then turn it on in production in a probation mode and just learn from the reality of the systems over time and fine-tune itself. AI as any of your constant improvement type of initiatives, this is just another way of leveraging something that will learn to become better over time. So it's, small improvement, but continuous improvement is typically what you can expect of AI systems. And in this case, we looked at the robotic movement, the amount of resin that was injected, the tension of the composite tape that was deposited, and yeah, see if there's too much resin, not enough resin, too much tension, not enough tension. All of these kind of telemetry signals produced in combination different defects, and we were able to reduce and find the root cause of a third of those in real time. That helped a lot. Smart buildings, cooling optimization. This is an example at scale where they're using millions of real-time telemetry sensor, and they're able to make sure they hit the right cooling amount. So you can imagine in a server room environment, if you put too much cooling, you're wasting money, and if you don't put enough cooling, you burn up your server. So you better be just at the right level between the two, because that in both cases money's involved, and so the control and the performance have to be just right moving forward. And these thousands of servers in these different servers room presented a great example of how to leverage AI technologies. Maybe one last one on the fleet digitalization case. So this is, on the marine vessel. These are mini factories, really floating factories around the planet. Of course, if you think of network availability, sometimes it goes through a satellite, sometimes it goes through LTE when you're close to a port. All of this generated some interesting new constraints for us from a delivery standpoint, and we were able to overcome all these latency issues and other things for optimizing the operations, and we've done a lot of fuel savings, huge savings actually on the fuel side, and improving their regulatory tracking and predictive maintenance. So this is more of a vessel type fleet kind of example, but always in the industrial space. So with all that said and done, how do you envisage getting started or getting AI ready or machine learning ready? So we have another final poll for you. I'll launch this poll here. So essentially, do you intend to build your own data science team? Do you want to augment your own existing data science team with external industrial AI specialists? Do you want to outsource complete AI projects to a firm like Maya HTT? In all cases, we'll look for your components. Most people will want to build typically their own data science team, and in those cases, again, Maya can act just as an advisor to help you get started and help you build the right team. We've built many teams over the last decade. And with a very focused approach in industrial AI and industrial machine learning. So you might get some good tips and tricks on how to really use best practices to get started with your own team. And a lot of people will typically want us to augment their existing team in many cases. And in smaller cases, typically, I'll see if today is, I think the voted is getting close now. It's still voting a little bit, so I'll wait a few seconds. But some people will want to outsource entire AI projects. But even in those cases, what we would recommend is having some custodian that will slowly become the owner of the adoption down the road. So there's still some governance and some things that are needed at the client side, even when you outsource projects. So let me close this one here, and let's share the results as usual. So 53% of you will want to build your own data science team. So that was, I think, very expected from my standpoint. 37% would like to augment your own data science team, and last 10% outsource entire AI project. So in all these cases, if you want our help, of course, reach out to us after this webinar, and we can help you either build your own team, augment your own team, or deliver entire end-to-end AI projects for you. Perfect. And to finish here, you know, a lot of you will want to get started. As you get started, proof of value, and make it small but MVP, in the sense of make it a real deliverable in a real adopted environment, and put it in what we call a probation mode, so that you put a machine learning alongside the previous whatever signal that was there, or on the same human interface that you had before, and just add a signal that will help people, like maybe augment temperature, lower temperature, and just give tips and tricks on what to do to improve their situation as they go. And that helps onboarding, it helps understanding the value, and then you track the metrics, and over time you just improve the AI model as you deploy, and at some point it becomes something that you can leverage you know, and rely a lot more on over time. So that's kind of the typical approach to a successful AI adoption, at least in the industrial environment. This is where we've deployed the 150 projects that we've deployed, and we've leveraged now and fine-tuned this approach over the last 7 years. And yeah, that's now been proven to work very well for our clients. So we will open the floor for question. Francis, you can maybe look at the various questions we got from the audience. I'll let you drive that portion.
Sure. I think there were some general questions about the webinar itself, Remy, that you can help with this in terms of the material and the recording.
Mm-hmm. Yeah, the material and the recording will be made available to the attendees. So the link to the recording will be sent in a few days, and the material can be made available as well. You can simply reach out to us. You have my email address here on the speaker info, and I'll be glad to engage with you and provide you some of the material here.
So I think there was another question about, you know, the AI approach, how it's better than a human being the programmer. So I think it's more of a generic AI question. And while the algorithm is built by the human, how does it get better? And that's something we're looking for an example.
So that's a very good question. And yes, I mean, human beings are very good at seeing patterns in data as well, but typically the scope of what they can look at and comprehend is very narrow. So an expert that's been there for 30, 40 years will understand the machine and the settings in the machine. And because they've tried and trial and error, right, different things over time, they'll know what works, you know, and what doesn't work, but they may not know what is the best kind of combinations of a few or many parameters that you can control. So I'll give you an example on the quality side, going back to the pulp and paper. Out of the 600 parameters, maybe there were 60 of them that were controllable parameters that can actually affect a change in the quality parameters. Only 3 or 4 were actually used on a regular basis by the technicians on the shop floor. Whereas when we turn on machine learning to help, all of a sudden, the 60 of them were leveraged to fine-tune the model. And in the end, maybe 30 of them were really the useful, more impactful ones, but it was definitely 10 times more than what the humans on the shop floor were using before. So those are all, interesting kind of parameters that, because machine learning will learn from all the data available. Now, that's the curse of having data. You need to make sure your data pipeline, the quality of data, that you safeguard the machine learning model, because if you garbage in, garbage out, if you submit garbage to a model, it will not do very well all of a sudden. So we have built practices also around the data, right, and the data custodian. So a data strategy is always needed, also aligned with the AI strategy and machine learning that you deploy in production and manufacturing. So those are certainly, hopefully, good examples that answers your question.
Right. Yeah, I'm just going to, in interest of time, combine a few questions here. It's about the experience of companies with AI. What is the right way to approach it, or what's been the the learnings? And I think about the size of companies, which are the size of the teams, or the focus teams that are working on AI for different companies, and kind of taking those questions combined.
Yeah.
One of the key things is, I think, as Remy mentioned, making sure that you are identifying the right use cases where you balance between complexity and value. And the second is looking at something that you have the ability to scale. And the example he talked about quality and being able to have a problem where there are hundreds of parameters that could potentially have a play. Being able to whittle it down to the key attributes or parameters that are contributing factors become that's where you optimize the journey with AI. And that's part of what we talked about foundationally when we said the data pipeline and the quality becomes key. The use case and the context where you can bring in some of those insights and whittle it down to the core focus of the AI problem becomes key. And then being able to scale it. And most of the projects that I have seen the customers get little success or probably no success is where they have tried to take on something way bigger than what they had the resources to address in terms of the know-how, as well as something that they could never take it beyond a machine or a specific set of machines, because it inhibits your ability to add more value.
Yeah. If I can just augment your
top of the hour here, so I don't know if you have a minute for another question, real quick.
Yep, go ahead.
I think it's about ingest rates and the quantity and qualitative data aspects and how we address that. I'll take a quick stab at it from a data perspective, because we deal with data which I call have a play from a real time versus near real time. So we leverage edge when it comes to real time aggregation of data, and AI models run at the edge. When we talk about near real time and bringing data from a larger context, it could be from ERP systems, it could be from multiple sites, historians, etc. Those become use cases which you can tackle at the cloud. And of course, you look at optimizing the amount of data that you need to keep on at the edge versus the data that needs to find a place on the cloud for training the model and then, of course, deploying it. Remy, if you wanted to add, please.
No, I mean, that makes sense. And maybe just to augment your previous question on the small, medium, large size of enterprise, in our 150 clients, there's 20% were startup clients that were much more focused on the after sales value add services from their startup components. And then 40% were medium-sized businesses, and 40% were very large to extremely large enterprise. So at any point in terms of your evolution or the size of your company, that's not really what matters as much. What matters as much is, the business use case, as Francis mentioned, that you select the right one and the one that will be perhaps the shortest and smallest in scope to start, right? To put the right piping in place and the right infrastructure, and deal with the change management, because there are people involved, right? They need to know that it will augment them and not replace them. There's a lot of buzz out there, and fabulation on AI taking over. Today and for foreseeable future. It's really on the augmentation of human beings on the shop floor that are there, or augmenting the process and the controls that are already there. And from a data perspective, I don't have much to add there, Francis. I think we're 100% aligned. The edge device for near real-time kind of feedback to the local components. And then you have a lot more time on the business side for the analytics and the other dashboarding they can bring on the Insights Hub dashboards. So on that note, I think we'll close here. If you have any more questions that you'd like answer, or you'd like to engage with us, Francis and myself, to look at your business use cases or help you augment your own team or take on big AI projects for you, you can contact us. You have our information here. And if you want, you can screenshot this little podcast QR code. This is one interesting, one of my latest interesting podcasts with Siemens on ChatGPT and large language models and how they're applicable in your space. And again, mostly for technicians to look at getting a chat-like interface with their technical documentation to help them solve problems and troubleshoot problems more effectively. That's one use case that we've looked at with our clients. So in any case, I hope you enjoyed our session today. Francis, thank you so much. Bring the value, and collaborating with you is always a pleasure. Hope we get to do a lot more together.
Sure, thanks. Thanks, Rami, and thanks for the audience for your valuable time and share this experience. So hopefully we start the journey somewhere soon.
Excellent. See you all soon. Cheers.
Thank you. Have a good one.